Hello class, these are our notes for 2-7. We are writing polynomial equations from x-intercepts and zeros. So these are our Algebra 2 notes for the day. So we can use the zeros of a polynomial to figure out what an expression for the polynomial might be. So let's just do a quick little review. If I have a function p of x equals x minus 1 times x plus 2 times x plus 3, then the way I would get my zeros is I would make my function equal to 0, and I would solve with zero product property. And so I'd have either 0 is equal to x minus 1, or 0 is equal to x plus 2, or 0 is equal to x plus 3. And because of the way I solve, and I'm like subtracting on both sides, when I find my zeros, they're opposite in sign, right? My zeros for this one would be 1, -2, and -3. So my 0 is a positive one, but I have a factor of x minus 1. So now we're working backwards. They're now going to give us the zeros, and we have to write some polynomial functions. So my polynomial for the first one, they're saying h of x, so h of x equals. So if they give me a 1, that means I have to have a factor of x minus 1. If they give me a 1/5, I have to have a factor of x minus 1/5. And we'll talk about that in a second. I'm not a big fan of that fraction. And then if they give me a -4, I have to have a factor of x plus 4. So I really don't like the fractions within a factor like that. And many of you wouldn't like graphing something like that either. So what I could do is I could basically just multiply this by a 5. And then we have 5x minus 1. And the reason I can do that is, let's think about x equals 1/5. And if I multiply both sides by 5, I get a 5x equals 1. And then I subtract 1 on both sides, I get 5x minus 1 equals 0. So this is like a factor. And then this is like solving it for the 0 and working. So basically I've like worked it backwards. I've started with my answer, x equals 1/5, and I've worked it backwards to find that factor. So I really would prefer to write that as a 5x minus 1. All right, so they want to make another polynomial function that satisfies that. So I could put a 3 in front. I could put any kind of constant in front, right, without changing the value. And I could even add exponents to my factors. If this one's squared, it doesn't matter. It just means that I have that 0, -4 that happens twice. There's a multiplicity to that solution. It's going to do something to the graph that we'll learn about later, but it doesn't change what my zeros are. I could make this one to the 3rd power. So we can add in constants and we can change our exponents and still have the same thing. Sorry, I keep doing this right now and I don't know why. Okay, on the next one, write a function if you also know that the y-intercept of the polynomial is 12. So let's take a look at this right here, the first one that we made, and we're going to figure out how to adjust it. So we're going to write adjust, so y-intercept is 12. So we're going to adjust it by multiplying by a constant, okay? So I'm going to write down h of x equals, and I've got x minus 1, I've got 5x minus 1, I've got x plus 4. So let's go ahead and look at the constant parts of that, the -1, the -1, and the 4. And if I multiply those together, 1 times 1 times 4, I could ignore negatives. 2 negatives makes a positive, would give me a positive 4 right now as a y-intercept. But I want 12. So that means I need to multiply by 3. We could also get that by looking at 0, right? You could have 0 minus 1 times 0 minus 1 again times 0 plus 4. I guess really it's 5 times 0. That's -1 times -1 times 4. It's currently 4. If I want it to be 12, I need to multiply by 3. That's where that 3 is coming from. Now it's 12. So I'm just saying, rather than put in all those zeros, it is possible to just look at the constant parts of all those binomials. So because it's a 4, I need to multiply by 3. Now I've got an answer that works. All right, you're going to check your understanding Pretty short and sweet notes today. So go ahead and pause right now, try it, and then come back for my explanation. So we've got 4 zeros on this one, so I'm going to write h of x equals. X is 0 just means I have to have an x being multiplied by everything. Negative 2/3 means x plus 2/3. I'll adjust that factor in a second. You know I don't like those fractions. And then I have an x plus 1, and then I have an x minus 2. So always opposite in sign. Now to change this guy right here, I multiply by 3, which means this is going to be gone when I multiply by 3. And so there's my answer. And I just want to clean this up because it's bugging me. So 3x plus 2 instead is what we said. Okay, so now my next step is to go through and, oh, I have to make another one. So now I'm going to put a 7 in front. I'm going to make this one squared, the other one to the 5th power. So remember, you can add in any constant and you can add in any exponents. And as long as the factors are the same, you're good. As long as you have the x here, the parentheses with the 3x plus 2, the x plus 1, the x minus 2, then you're fine. All right, if I want to make this have the same zeros and a y-intercept of 8, so now I'm going to take this guy down here and I'm going to adjust it. By multiplying it by a constant. So you could either just look at all of the constant parts of this. Uh-oh, we have an x in there. Let's look at what happens when we put in a 0 to find our current y-intercept. This x is doing something weird here, right? So if I find h of 0, I get 0 times 3 times 0 plus 2 times 0 plus 1 times 0 minus 2. That's just going to equal 0. It doesn't matter what we multiply this by, because we have an x-intercept of 0, the y-intercept has to be 0 as well. So we're going to write not possible, since there is an x-intercept of 0, the y-intercept must be 0 as well. All right. So big thing today is just we're working backwards. And so we're taking whatever our function is, or whatever our zeros is, and then we're writing out the function now instead. All right, as always, if you need help, please make sure you ask.